Hello everyone, welcome to Ask Geology, a whole new way to understand our Mother Earth. So in this today's 7-minute numerical class, we will be discussing about one numerical related to your petrology. Basically this is a conceptual numerical. Okay, this is related to your phase rule. So the question is given to be in the hypothetical ternary liquidus diagram. You can see this is actually a ternary diagram because we have 3 end members. That's why ternary. If 2 end member, then that would be binary. If 4, then quaternary. Simply ternary liquidus projection diagram. There are so many of like types chemostatic diagrams. Okay, there are projection diagrams, simple projection. Okay, or from any particular point of projection. There are so many of chemographic diagrams. Okay, so given below solid phases A, B, C, D and E. You can see A, B, C, D and E. This is this E. Okay, A, B, C, D and E exist in equilibrium. Okay, exist in equilibrium with the liquid. The reaction taking place at the isobaric invariant point W. So he is, or in this question they are talking that this point W is an isobaric invariant point. Why isobaric? Because this is an experimental setup, okay, where the atmospheric pressure 1 atm pressure is fixed. So this experiment has been conducted by taking the pressure to be fixed, that is 1 atm pressure. So pressure is fixed, that's why it is isobaric. And invariant point, why invariant? Because we know that at invariant point the degree of freedom that becomes 0. Okay, the degree of freedom that becomes 0. So this is basically mineralogical phase rule, that is your invariant point. That's why, and this W is an isobaric invariant point. So they are asking at this point, W point, isobaric invariant point, what would be the reaction if we have A, B, C, D and E phases. They are at equilibrium with the liquid. With the liquid means the liquid W. Okay. So we can see that for equilibrium, okay, you can write down one equation like A plus of B is equal to C plus of D. In which condition? When this is in equilibrium. Okay, for inequilibrium condition you cannot write down an equation giving the is equal to sign. Okay, so for equilibrium condition then you can give the is equal to sign. Okay, so in any particular equilibrium condition that will be satisfied by a scientific equation. Okay, so at any equilibrium condition we should be able to write down, or we should be able to just derive one simple equation, okay, by giving the is equal to sign. So this point, and what are the possibilities for just deriving such reactions, okay, in our phase rule types or phase rule concept. Okay, so we know that it's simple, this is A and B and in between there is C. Okay, so this is basically, we know this is actually a peritectic type reaction. This is actually a peritectic type reaction. So what will be the reaction if A and B are the end members and you are getting the C point? Then what will be the reaction? A plus of B, they will give rise to C. Okay, and this C point can be represented by this A plus of B. If we just write down A plus of C is equal to B for this reaction, then A and C, we have A and C, but this B is falling outside. So like we cannot represent the point B if we have only data A and C. And similarly, if we just write down C plus of B, that is equal to A, or A is equal to C plus of B, then we cannot just represent that A point by the help of C and B. But you can see that in this reaction we can be able to, if we have A and B, then we can just represent the point C, or we can define the existence of point C by using A plus this reaction. So these are invalid reaction and this is one valid reaction. So this is one type of reaction, equilibrium reaction, you can just write down. And what are the second type? Like if it is a cross-cutting relationship, A, B, C and D. Let this point to be, let O. Okay, and this O is the equilibrium point. Equilibrium point. Okay, so this O point, it should be represented both by this AB line and CD line. So what is that possibility? You can see there is only one possibility in which we can define the O point by taking both AB and CD. Okay, we can say A plus of B is equal to C plus of D. This is actually the equilibrium condition. Okay, so at only point O we can be able to just write down this reaction. Okay, at point O you can see that at this point O, both A plus of B, this O point can represent A plus of B and C plus of D. But if I just write down one point here, okay, one point here, let this point to be X, then this X point will only represent C and D, but it will not represent the A and B. Okay, so here the equilibrium point at point O, we can only derive one equation, that will be A plus of B plus of C. A plus of B is equal to C plus of D. This type of reaction is called your tie line flip reaction. This is tie line flip type reaction. And what is the third possibility? If I have three end member, let A, B and C, and my composition is falling in between this, let this to be 0, sorry, O, then I can just represent the existence of O by using the A, B and C. Okay, I can write down A plus of B plus of C is equal to 0. O, I can define the existence of O by the help of A, B, C. If this O point, let I just take this point to be X, so can I write down A plus of B plus of C is equal to X? I cannot be able to define this point X by using only A plus B plus of C. This type of, so this reaction, you can write down for an equilibrium reaction, but this is not an equilibrium reaction. Okay, so this type of reaction is called your terminal reaction or end member reaction. So these three types of reactions are possible to define a equilibrium condition. Okay, so in this question just we have to find out that at point W what are the phases present. Okay, in this diagram you will be just looking at like the equilibrium reaction at a particular point like X, Y, Z and W. Okay, and you will also have to write down equilibrium reaction on the cotectic or these curved cotectic curves, or this whether they are cotectic or whether they are showing any kind of peritectic relationship. So you have to write down one reaction for a particular point as well as on the line. Okay, on the line, better to say on a curve, because these are curved surfaces, curved lines. Okay, so we can see what are the phases present at W. We can see that at this point W, this is at point W, E is present. You can see the W is just touching the E field. This is B field, this is D field. So what are the possible phases present at W? Okay, W में कौन कौन सा phases अभी stable है? So you can see that E phase is stable, E है, and there is B and there is D, because this is D plus of liquid, this is E plus of liquid, and this is B plus of liquid. So we have 1, 2, 3, 4. These 4 phases we have at point W, and this W is basically representing your liquid W, better to say liquid W. So what are the possible, you can see what are the possible reactions, what are the possible arrangements we can just make. Okay, so in these, from these three conditions, which condition is best represented here? You can see that if I just take the end members B and D, B plus of D plus of W, liquid W, then I will be representing the E. Is it fine? Isn't it? So you just see, just let me some time, give me some time. Okay, if just write this peritectic relation, the equation 1 is not like, this is not representing or this cannot be applied in this section. Okay, and this tie line flip, just we saw that this B, D, W and E, they are actually stable at this W point. So if I just want to draw a line and this one, they are not cross-cutting inside, they are cross-cutting outside. So at this particular point I cannot be able to write down one equilibrium reaction. Okay, so like I have this point B and E point, so I cannot just extrapolate this one. If the equilibrium, if the the cross-cutting point should be like, if this E is present here, then I will be able to write down the cross-cutting relationship or the tie line flip type reaction. But it is not happening in this case. So what is the last possibility? Just if I just want to just say this triangle, okay, I'll be able to make this triangle, and inside that the E point is present. So I can say that I can represent the point E with the help of W, B and D, isn't it? And this is the only possibility, and this we can write down as a reaction, like liquid W plus of B plus of D is equal to your E. Okay, and you can see that this E plus of liquid, this E solid phase is represented here. We can see that this is the E point. Okay, so our answer will be liquid W plus of B plus of D, that will give rise to E. So the answer here is D. You can see the answer here is D. I just want to say one another thing, that whether you will know, how you will know that whether it is a crystallization or a melting. Okay, whether it is a crystallization or melting, actually they have not any kind of sign. Okay, so direction of the reaction, and they have only, this is a hypothetical question, they only just asking the reaction taking place at point W. Simply, if it is crystallization or if it is melting, if it is crystallization, then the bulk composition will move towards the point X. So what will happen at this point? Liquid W, B plus of D, they will give rise to E. And if it is crystallization, the bulk composition led somewhere, this bulk composition, it is moving to this point, then it is going further. Then at this point the degree of freedom is equal to 0. That's why it is saying this is isomeric invariant point at W. So at that particular point W, the equilibrium reaction will continue for some time. Okay, and after that this degree of freedom, okay, the degree of freedom, that will change from 0, otherwise the reaction cannot move. Okay, for a reaction to move in a Tx space, temperature composition space, then we need a degree of freedom. Okay, if it is invariant, if the degree of freedom is 0, then we cannot move in a temperature Tx space. Okay, so to move, if I am just saying that this reaction, if it is crystallization, then the reaction will move from W to X, and to move from W to X, it has to gain some degree of freedom. Okay, this degree of freedom right now it is 0, it has to gain something like F to be 1. If it will gain some degree of freedom, then it will be then it can move on the temperature pressure Tx temperature composition diagram. Okay, so this is basically the our answer is liquid W plus of B plus of D, that will give rise to E. Okay, and these are the 3 possible type of reactions we can deduce to define a chemical equilibrium in our phase rule concept. So we will be discussing, I will take a separate class for this one. There will be a complete video for 2 and 3 types of your ternary phase diagrams. Okay, so up to here, any doubt? If you have any kind of doubt, you can write down in the comment section, and if you want any numericals to be solved, you can also comment in the description box. So thank you very much, and if you are very much interested to join our group, the Ask Geology group, then you can just simply text to these numbers or just put a mail here, and you can simply just click on the links below given in the description box to join our respective social media. Thank you.